array of binary strings like this. And two numbers m and n, and we want to find the maximum size of subset from this array. Subset maximum size that has zeros less than m, ones less than n. First of all, convert the strings from string to just counts of zeros and ones, and you will have numbers of like count zeros array. It will be like 0, 1, 2, 5, like this. And count ones, and the next is how can you find a subset that has the most, like the maximum size, for example, and count of ones should be less than n, count of zeros should be less than m. How can you start to think on this problem to have an intuition to solution? So first of all, what is a subset? Subset is when you have an like a bag of numbers or anything, and you picking any kind of values from it, any number from any positions. You can pick like one number, zero numbers, three like this, or three like this, and so on. This is a subset, and to find the subset you have to try every possible number to pick it or not pick. So when you picking some number from a subset, you have a tail of your numbers, and the problem repeats for this tail. So given the picked numbers, you repeat the problem of picking the next or not. So if you pick, like if you take this number, you just doing +1 to the size of subset, and then you go to the continue calculation. And if you're not taking, you're not doing +1, but you're still going to repeat the calculation for the tail. And after that, you have the result for the tail. So you have result for take and for not take. And while you picking the number, you increasing the number of zeros and ones, how many of them you have, and comparing them if your pick was valid or invalid. Like if you're taking zeros and they're still less than m, and one still less than n, that means your pick was successful and you can continue. And when you end at end of the array, size. That means you're done, basically finished, and you can return the result. So when you have the result for take and not take, you must see if it was success or not. So for success you just return 0, and for not successful you return some negative value. And if they both are successful, you choose the maximum of the peak or peak plus 1 and not peak. Peak plus 1 is just the length. And basically this is a depth first search, because at every index position you try 2 variations of taken and not taken, and then you're repeating this for the next position. And this is kind of tree or binary tree, and this binary tree can be memorized because you can have similar tails. When you're not picking something, you can have similar calculations, and you can use hash map to store them by k. And what is the k? The k is just the arguments you taken. You have position that the peak was, or just begin of the tail. Then you have how many zeros you've taken and how many ones you've taken. And this is a k. So this is dynamic programming. I solved it with top-down recursion, and it's pretty, I would say, simple to write this code. You cannot think of a huge problem. You have to think of just one single step at position I. So you have previous choices, it's number of ones and zeros, and you have current choice, and this is your k, and this can be encoded into a single like int or long value for the hash map. Then you check if you're not overflow with the taken zeros and ones, and also you check if we add finish. Then you have to do both the calculations for take and not take. You can't just use the take because it's not obvious that this will be more optimal than not taken. And both of the children is good. Just take the maximum of the taken value. You have to do +1. For not taken, you just use the result. And also you have to check if any value is good, you have to return it. And if not, you just return the -1 as a marker of the wrong result. So that's it. Also, there can be any possible optimization. For example, the number of zeros is the length of the string minus number of ones. So this is not necessary. Also, you can rewrite this into bottom-up recursion. It would be a little bit harder for the idea, because in that way you have to think of the entire problem, and the depth first search top-down is just a single choice intuition. Yep, my solution take 200 milliseconds. It's not optimal because the bottom up is much faster. It's also taken less space. So the time complexity of this variant is of the size of array is n, and then it's number of zeros and all ones times, I would say, length squared. And the space, it is time complexity, and the space complexity is the same because this is a hash map. This variant is more elegant, but you have to think of this DP like the different intuition, and you can't just describe it. I can't describe it as simple intuition. So it's basically we count, we gone from string to string, and then we doing this 2D dynamic programming, and we go from the tail to the head and updating the current value. This is a not take, and this is for the take. And each time we do minus zeros. So if it's, I would say it's the intuition of updating the dynamic programming matrix by the fact that we chosen this current string, and if the choice is better, we take it. This is how I describe this intuition.